what I'm so interested in though is there's the future of healthcare, as far as I can tell. Everything is moving towards computers and computation, just as a broad term, AI and everything in between, is certainly going to be a part of all the future of healthcare, without a doubt.
Right.
And you've got this way of diagnosing things, and ideally early, right? That's if you're looking at biomarkers, you can see this stuff way before it's detectable in a scan.
Yeah, we just announced autism with Ignite Biomedical, the same folks that we did SUD, and we're detecting autism with biomarkers in kids well under 2 years.
Really?
Yeah.
Do you have a degree of accuracy on that? Is it
It's
100?
greater than 90% sensitivity and specificity.
Wow.
And we replicated across 13 data sets, 13 different patient groups.
How early could you pull that from a fetus?
Well, it's interesting because one of the data sets is cord blood.
Okay.
Now, there's the big debate. How much of autism is genetic versus environment? And there's two kinds of environment. There's the motherly environment of the womb, and then there's post-birth. Well, the cord blood presumably reflects genetics of the baby plus the 9 months in the womb. So there is some form of environment. And, RFK is talking about acetaminophen. I don't agree. But the question is, how accurately can we diagnose autism from cord blood? Because they had to wait. They took the cord blood, then they waited for the kids to get older, and when they got diagnosed or not after a certain period of time, then they marked the database with yes or no. And our job was to basically predict, are they going to develop autism? What's interesting is the accuracy on all the other data sets is above 90%. On that one, it's around 75. And let's think about this. The best accuracy you can get is 100%, right? Sure. The worst accuracy is not actually 0, it's 50%. It's a random guess.
Yeah, sure.
Okay? So the difference between 50% and where you are all the way up to 100 is how much is genetics in the mother's womb. So it looks like about half of autism is a combination of genes and the mother environment. Now that could be all genes or all motherly environment. We know there are some genes involved, so it's not all mothers. But fully half of autism is outside the womb. It's environmental. So that's a nice exercise.
But Patrick, could you have the certain genes set up to, let's say that every human being is going to get exposed to the same environmental condition, right? And
yes, and some genes will predispose you to that environment, giving you autism, and some won't.
Yeah, so it's like the genes could be there, but perhaps it's because we're not gonna go down the vaccine route, but perhaps one particular vaccine that everybody gets, you combine.
Yeah, let's just say lead paint, right? Because nobody is going to get triggered by lead paint, right?
Yeah.
So, I was born in '65. In all likelihood, I was exposed to lead paint growing up. Right? It was just used in various dishes and houses and everything else, and somehow I didn't develop autism. That may mean that either I don't have sufficient genetic components to be triggered by the lead, or that there was something else that helped me not get it, right? But there are definitely both, right?
When you find this stuff, do you publish it and make it public, or is it like your trade secrets?
We do publish some papers, but peer-reviewed papers are extremely hard to get published these days when you're using something like evolutionary computing, because the reviewers don't understand it at all. What we've done is we've got a paper out now that explains the technology, and it's for the TNF inhibitors we licensed also to Ignite Biomedical. Okay. And that we're using now as a foundation for the credibility for other papers, so we can just refer to it.
Gotcha.
Anything new is, like I said, the dogma in medicine and science. What's really funny is, why should our stuff be considered new when life has been around for 4 billion years on Earth and evolution's been operating?
It shouldn't be, but I don't think people get it. I mean, I'm the average person can't even natural language processing models. Like, we're at a point now where most people can't wrap their heads around the concepts that are driving forward.
And that's understandable, right? Yeah. I can't throw a 105-mile-an-hour pitch, right? So,
but I think it could get there. I think it starts with the potential outcomes. Like, if the public sees that that if you had free reign, you could do whatever you want. You could develop a test for everything. You could be testing people from an early age for all sorts of different sicknesses and illnesses. And early detection is the key to survival.
Right. And we can do genetic testing, right? We've worked on genetic data sets as well. It doesn't need to be RNA or proteins.
Okay.
Doesn't matter to us. As long as the data are measurements or categories, we can use it.
So the average person sitting here listening to this, if you had the keys to the kingdom, you could produce tests, they could be tested, insurance pays for it, and they would know way ahead of time if they have any kind of the big scary cancers, cardiovascular. I mean, how many different?
Well, we have the ones that we have that are being commercialized by partners right now are in pancreatic cancer, breast cancer, lung cancer. With a Mayo Clinic, we have a joint venture in kidney cancer, not only diagnosis, but staging and recurrence. So yeah, it doesn't, and we've done Alzheimer's, Parkinson's, ALS. We're about to do frontal temporal dementia, which nobody wants to develop drugs for, because when you recruit, you accidentally pull in a lot of patients with other dementias that are biologically different. So the drug doesn't look like it works, right? So I would love to take the diseases and just say, biggest prevalence to least prevalence is in many in parallel as we can, just start going down the data sets and handling them.